Hi, I'm Dan Brusky, Product Manager for the Industrial Instrumentation Sensors, which includes level measurement and pressure. There is a video on pressure measurement. Now we're going to go over level. One of the big pieces of literature, important pieces I would say to take a look at, is this level and pressure overview. Part number 8012972. You'll find this on our portal and in the launch information. And it goes over level and pressure measurement. And it talks a lot about the different types of level measurement that we do. An important thing here I want to flip through is the different technologies that we have. So we have microwave probes to forks, vibrating forks for level measurement, ultrasonic sensors, capacitive sensors, optical sensors, scanners, all sorts of very interesting, good level measurement tools and technologies. One of the new ones for SICK here we're going to be talking about is in the industrial instrumentation area for doing level measurement. So one of the technologies we have, as you heard me mention, is a microwave. So basically what we do is this is just like an optical sensor or an ultrasonic sensor where we send out a pulse of energy, it bounces off of a surface, and we count how long it takes to get back. So in this case, we're putting out a pulse of microwave energy down basically a rod in here and guided by this outside piece. And it has slots or holes in it to allow water to go in, and basically where the microwave hit the water, we count how long it takes to get back. Right now it looks like I've programmed the output Q3 for, whatever this level of water is. Maybe that would be you're running out of water, you're running out of hydraulic fluid, or an overfill condition. This particular sensor here has 4 switching outputs. We have other ones in other shapes and sizes and lengths that have analog output and switching output. We have another shape here that is basically the same microwave rod, but it doesn't have that outside casing. So this basically needs to be put into a metal container, and it basically does the same general level measurement. So we'll do a little bit of programming here on this one, just to get used to it, because it's a single button programming, which makes it easy, but then also you kind of do have to take a look at the different ways to measure it. And for that, I would really refer to the product insert that comes with the sensor. It goes through all the different types of programming that you can change, window modes or just regular switching modes, how to do the analog output. So one of the things, I'm going to program Q1 for a different level. So I'm just going to maybe make it a very shallow level output. So one of the first things I would recommend doing is pressing and holding this button for over 15 seconds to get it back to factory defaults, just so you know where you're starting from. So I did that already. So now what I'm going to do is I'm going to push this for a little bit more than 2 seconds. Basically, you're either quick pushes for less than a second or pushes that last longer than a second. So I'm going to push it for longer than 2 seconds. And then during all of this, I actually don't have to have it in the water, but it's a nice resting point here. So I'm going to press it for more than 2 seconds, and we'll see something change in the output. So basically, this green light is flashing, and it's telling me I'm on Q1. If I push it quickly, I go to Q2, go to Q3, go to Q4. Basically, I'm selecting the output that I want to teach. It all flashed, telling me I'm at the end. I hit it back, and I basically cycle all the way back. So I'm going to start right here at Q1. So I'm selecting the one I want. And I'm going to press for more than 2 seconds to choose to set basically an upper threshold signal level. So 1, 2, and you'll see a light change. So now basically we have a different flashing mode. If I leave it here, basically I'm just going to set one switch point. There's a couple other modes here where you can set an upper level and a lower level, basically almost like a switching hysteresis. But I'm just going to make this real simple here, and I push that. So now I'm going to push again for more than 2 seconds. 1, 2, and you'll see it start toggling. It tells you, okay, something else happened here. And at this point, the rod does need to be in the water, so we're right here. So, and what I'm going to do is I'm going to move it to a higher set point. I'm going to push it for less than 1 second, and the lights start toggling really fast. Now basically I just kind of wait. Because right now I could go through and teach Q2 to a different level, Q3 to a different level, Q4 to a different level. And when you're done teaching, basically I don't have to hold it in the water here, but it's going to kind of go through and say, yep, I think you're done, you haven't programmed anything else, so it'll go back into run mode. And then what we'll be able to do here is see switch point Q1 be at a shallow depth, and then Q3 being at a little further depth. Okay, so now it's done, the green light's on, I'm out of the water, I'm going to enter it into the water, I hit the depth that we taught it, Q1 turns on, and then there's the Q3 we have kind of at the bottom. So basically you can go through and you change. You can set up 4 switching outputs, or like I said, on other models we have 2 switching outputs and an analog output, so you get a continuous measurement value. So that methodology works basically for any of these lengths up to 3 meters of length for these rods. Another way to do level measurement, if you don't have a liquid, if you have a bulk, is you can use a vibrating fork. So here I have one particular fork set up. They come in hygienic versions, short versions. They have ones that has a big tube extension. We have ones that can extend out to many meters, to basically go all the way down to the bottom of the tank for a run dry warning. Here for a level measurement, I just have some non-dairy creamer. And this particular sensor is an LBV. L is for level, B is for bulk, and V is for vibrating. So a B is for bulk. There's versions of this. Let's say take this one. This is an LFV. That would be level fluid vibrating. So this could detect the water level. This is set up for bulk. So I don't know if you can hear it or see it buzzing there in the video, but basically right now this thing's making a tuning fork style buzzing noise. And you can even see it vibrating. If I touch it, the vibrating stops, or at least it changes, and then I get a switching output. So for the switching output, you can set up the output wires. In this case, this sensor has a relay output. So I basically took the cap off the top, and so it's nice and sealed. So I took this off the top here, and I just basically, you can set this up with a relay output. We have PNP, NPN, these relays. But really, I'm just going to take a look at this green light here, especially for demonstrating purposes. And it's on. I put my hand on the fork, stop it from vibrating, and the output goes red. I can also hear, since this is a relay device, I can actually hear the relay click. Take my hand off, it clicks, I hear the relay open back up, and the green light turns on. So now I'm just going to put this into the non-dairy creamer. It's vibrating right now. It hits the bulk material, and the output changes. So basically I know there's creamer at that level. So if this were in a tank and it needed to be filled up, right now it's not at the right fill level. They keep filling up the powder, the grain, the oats, the flour, whatever it is, and it'll detect that bulk material. This can work for powders, grains, food, chips, screws and washers and nuts and bolts in a hopper that go into a shaker table. It can go into all those types of things and measure the output. And kind of last but not least on here for level measurement, these are ultrasonic sensors. These are standard ultrasonic sensors that we have, UM30 style, in our normal distance measurement. But one thing that makes these nice for industrial instrumentation is these can work. This one works in a pressurized tank. This is a UP56. I'm sorry, this is a UP56, this is a UP30. So this can work in pressurized tanks where our normal ultrasonic sensors can't. So you can use this for some of these processes. And this one, as you can see, is basically coated in plastic to be chemical and acid resistant, be able to be washed down, and just a little bit more industrial. Also can be handled pressurized tanks. This doesn't have the standard piezoelectric diaphragm that can get etched or eaten away. It's basically coated. So to look at what we have for options again, take a look at the pressure and level measurement brochure. Find that online. Also, there's a selection guide that helps kind of go through the different families of products we have. So we show the vibrating fork, fluid levels, the bulk levels, hydrostatic probes to drop down in wells or let's say wastewater treatment facilities, and these microwave type technologies. Show some pictures of where they're used and some questions basically to ask yourself or your customer of what do they need to know, what are they trying to measure, just a switching output, continuous output, what's their material, and help them to get to the right, not only the right family, but the right partner within that family. Thank you very much. Let us know if you have any questions.